Differential equation, an equation that contains derivative. An example of derivative, y double prime plus 2y prime is equal to 3y. Or in terms of function, um, the second derivative of function of x plus 2 times the first derivative of function of x is equal to 3 times the function of x. Or in terms of Leibniz notation, we can say that the second derivative of y in terms of x plus, or in respect with x, plus the first derivative of y um, in terms of dx times 2 is equal to 3y. These equations are the examples of differential equation, not just like algebraic equations. This function has answers of functions, or the solution of these equations are function. Solutions of these equations are functions or a class of functions. But in this algebraic equation, just like x plus y is equal to 3 or 3x squared plus y over 2 is equal to 4, or have the solutions of of any values, either constants or variables. I just wanna check or correct, or just to simply erase my handwriting. So values. These these two these two are different. The differential equation has a solution of functions, while the algebraic equation has a solution of values, either variables or constants. So go on, shall we? We say that the function, or the double prime of y plus 2y prime is equal to 3y is a differential equation. So example of its solution is y sub 1 with a function of x is equal to e raised to the power of 3x. Or to comply this equation, we need to find its derivatives. So the first derivative of y sub 1 is equal to negative 3 e raised to the power of 3x. This one right here, recalling the differential calculus, is the equation of derivative of EU is equal to EU, or the derivative of EAU is equal to AEU. So this explains this one. So I come up with that answer. So y double prime, so simply the derivative of this, of the first equation, or of the first derivative. So its second derivative is negative, or 9 times e raised to the power of 3x, or applying this equation again in the differential calculus. So to substitute, simply we have the y prime, y double prime, and y prime. simply we just need to substitute the equation. So in this y double prime, we have 9e raised to the power of 3x plus the y prime is negative 3e raised to the power of 3x is equal to 3. What is y? Y is e raised to the power of 3x. Thus, we just need to simply operate these values to ensure or to prove that this one right here is an equation of this equation. So 9e raised to the power of 3x plus or minus or oh, I forgot the 2 right here. So 2 times negative 3 is equal to 6 e negative raised to the power of 3x is equal to 3e raised to the power of 3x. Thus, this one right here will be 3e raised to the power of 3x is equal to 3 times e raised to the power of 3x. Thus, the solution or this function is a solution of this equation. Or again, to prove that that the differential equation has a set of function or a class of function, uh, I just need to prove the y sub 2 is equal to e raised to the power of x. Thus, I need just to operate again the first differential. So the first differential of y sub 2 is equal to ex. Then the second differential of ex, or the differential calculus of this one, or the derivative I mean, is e raised to the power of x. So simply substitute again the values into this equation. So y double prime is ex plus 2 times yex, or ex is equal to 3 times ex. In operating this equation, we come up, or we can conclude that this equation or this function is an equation of this, or is a solution of this equation. So this is the differential calculus or differential equation I mean. So differential equations has a solution of functions. So we have the second example. So y triple prime minus 3y prime plus 2y is equal to 0. And then prove that y is equal to e raised to the power of 2x is a function of this solution. So first, we need to find this one, or the derivative of y is equal to e negative 2x, to just simply substitute the values after. So y prime is equal to negative 2x, or negative 2 times e raised to the power of negative 2x. This one right here is again the differential equation, or the differential calculus, or the derivative of e raised to the power of u is equal to e raised to the power of u, or the derivative of e raised to the power of u is equal to a times e raised to the power of u. So I just need to delete this one to have a more cleaner paper. So y double prime is equal to negative, or negative times negative is positive. So positive 4 times e raised to the power of negative 2x. And then again, the y the triple prime is equal to negative 8e raised to the power of negative 2x. So let's go. We just need to substitute the the solved values in this equation. So for the y triple prime, we have 8e negative raised to the power of negative 2x minus 3 times the y. For the y prime is negative 2e raised to the power of 2x plus 2y, or 2 times e raised to the power of negative 2x. We just need this one to be equal to 0 to satisfy or to prove that this function is the equation or the solution of this equation. So this negative 3 times negative 2 is equal to positive 6, then negative 8e raised to the power of negative 2x plus 6e 2x plus 2e negative 2x raised to the power of negative 2x. These one coefficients here are equal to 8, which is 8 minus 8 is equal to 0. So this one right here, or the equations or the terms, are equal to 0. Thus, this function is an equation of this, or is a solution of this equation. Thus, this function, or the y is equal to e raised to the power of negative 2x, is a solution of the differential equation, or this one. So what if we we prove that this function, this y is equal to 3x, is, or we need to prove that y is equal to 3x is a function of this equation, or of this differential equation. So first step first step is we need to find the derivative, or the the, the notations right here. So y prime is equal to, I forgot 4. So y prime is equal to 12x cubed, and then y double prime is equal to 36x squared, and then y triple prime is equal to 72x. These equations is from the differential calculus, or the derivative of u raised to the power of n is equal to n u n minus 1 raised to the power of n minus 1. So going back to the main problem, so we have the values to be substituted. So we have y triple prime, or 72x minus 3 times 12x cubed plus 2 times 3x raised to the power of 4, so equal to 0. And then this one, 72x, we just need to simplify. 3 times 12 is 36, 36x cubed plus 6x raised to the power of 4, or is equal to 0. Thus, this equation, y is equal to 3x raised to the power of 4 is not a solution of the differential equation. So basically, the process of this lesson is to master the derivative. So, and then substitute the equation. So you just need to prove that this equation is a function or the of this function is a solution of this equation. So I will provide activity for you. Wait. So let's practice your knowledge. Verify each function is a solution of the differential equation.